So hello everyone. Today I am going to showcase my capstone project which I have recently completed, and the project is on AirBNB dataset. So before diving deep into the project, let me first give a brief introduction about this AirBNB dataset. So basically AirBNB is an online portal. It's an online platform where people can rent their house, okay, to the travelers. So Airbnb is basically, it was started in USA, and it has gained popularity in most of the countries. In India also we can see the metropolitan cities like Kolkata, Chennai, Mumbai, all these places. Airbnb is there. Okay. So coming about to this data set. So this data set is consists of both categorical and numerical variables. Okay. So there, this is the brief project summary that I have written, and this is the GitHub link which I'll be sharing it with you. Okay, you can access this collab sheet using this GitHub link, as well as I will be also uploading the dataset also. So first of all, let us view the problem statement. So what I've done is that I've done a brief exploratory data analysis of all the features, and at the same time I've also done a machine learning model of price prediction. Okay, so let us start with knowing the data. Okay, so first of all I have imported some libraries, general libraries. Okay, for example NumPy, Pandas, Matplotlib, Seaborn, okay, and Bornic. Secondly, I have converted this first of all I have imported this CSV dataset into the collab, and then I have converted this CSV dataset into a pandas data frame. Okay, so as you can see, I have written the code df.head, and you can visualize see this all. We can get all the data in this data frame. Okay, so uh, coming about the features, so there are total 16 features, 16 columns. Okay, and 48,895 rows are there. Okay. This then I have used df.info. So basically what df.info does is that it gives the data type of all the columns, as well as it also gives the null values. That means how many null values are there in this in individual columns. Okay, apart from that, number of rows, total number of rows are also there, so it also returns all these values. Okay, so here one important thing we have, one error we have seen, that later on we will be cleaning this data. Okay, and we will be getting rid of this uh, error, that last review data type is object. Okay, so basically the data type should be of date and time. Okay, so it's an object, so we need to clean this before moving towards data visualization. Okay, so now I've checked for duplicate values. So df.duplicate returns basically the duplicate, if there are any duplicate entries in the dataset. So luckily we are having no duplicate entries. As you can see, we are getting 0. Now we are going to search for missing values. Okay, so df.null returns the missing values. As you can see, most some of the columns are having missing values. For example, name, host name, last review, reviews per month, all these columns are having missing values. Okay, so now we will be finding that these missing values are there at to which extent. That means, say suppose let's go with a thumb rule. Okay, so if we are having more than 80% missing values in a particular column, so that means if we will try to impute also, so we will be getting a lot of redundant data, so there is no use of imputing. Okay, working with those missing values, so we can easily drop them. Okay. So I've constructed a data frame on percentage of missing value column wise. So here luckily we are getting the highest I'm getting is 20.56. Okay, so 20.56% of the data are missing. So we can go forward with it. We can either use a simple impute it with mean or median. Okay, so these are the data overviews and all that I've explained it to you. Okay, now this code returns the column, the name of the columns that are there. Okay, now df.describe this this code. Basically what it does is that it gives the statistical data of all the columns. That means what is the minimum value, maximum value, standard deviation, mean, median, all these data of each and every column it gives. Okay, so here I found something. Let me share it with you. Yes, this price is 0. So price, minimum price is 0. So this minimum price cannot never be 0. So we need to filter out this data. Okay, so that we will doing in that we will be doing in the wrangling section, right? Now we will be checking the unique values of the categorical features. So it's simple. I've run a for loop for the categorical variables, and as you can see, the data is gathered. Okay, so this comes to the completion of my first part. Now I will be going through the data wrangling. So that features that I have, that missing things that I have encountered in my previous exploratory data analysis. So now I will be cleaning all those anomalies. Okay, so first I filtered out the data that are less than 0. So this df dot price is greater than 0. Okay, and after that, now what I've done is, okay, now I've used so now I have taken the all the missing values in a separate data frame. Okay, so missing values I have done. Okay, and I'm checking the skewness of these columns. Okay, so basically what happens is that if the value of the column are having a normal distribution, so then we will be imputing it with mean data. If the data is skewed, either left skewed or right skewed, then we will be imputing it with median. Okay, and if we are getting a categorical variable, then it's simple, we will be using mode. Okay, so this is what I've done. I've checked whether the all these variables are skewed or not. So I found out that yes, they are skewed. So accordingly I have used I have imported the library from sklearn simple imputer. Okay, and I have just imputed all the missing values with median, and the categorical variable with most frequent value. Okay, so in this way I am getting rid of the missing values. And the last change I have done is that last video that I saw was in object format, object data type, that I have converted into datetime. From PD to datetime, I have converted it into a datetime. Okay, so this marks the completion of my data wrangling. Now we will be moving towards our fourth step, that is the data visualization. Okay, so first of all, I've broken down this data visualization into three parts. Firstly, we will be visualizing all the univariate. Uh, we will be visualizing the univariate analysis. So basically, univariate analysis uh, comes under those analysis that have only single feature. Okay. So for example, box plot, histogram, these are we deal with only one column. So these comes under the univariate analysis. Then secondly, the bivariate analysis are those having two features. So scatter plot, line plot, all these comes under the And thirdly, the multivariate analysis. The multiple features are there, so we get the multivariate analysis. Okay, so now what we do is we draw a box plot for each and every feature. Okay, so we can see the data set is highly skewed. Okay, so in order to get a proper picture of this skewness, what I did is I have log transformed the individual columns. So then also I can see most of the values are skewed. Okay, and secondly, what I've done is that I've plotted a histogram. I'm sorry. Okay, sorry for my mistake. A lot of outliers are there. Okay, extremely sorry for that. So lot of outliers are there in this box plot, as you can see. Okay, and the second graph I've plotted is of histogram. Okay, so as we can see that histogram are also very much skewed, and similarly log transformation I've done, and I found out that most of the variables are having skewness. Okay, now I'm coming to the bivariate analysis. Okay, so first chart I'm getting is of distribution of uh, count of neighborhood group versus uh, neighborhood group. So basically this parameter shows us that which neighborhood group is having the highest popularity. Count basically how many times it appears. Okay, so as we can see that Manhattan and Brooklyn are leading in this analysis, and Staten Island and Bronx are lagging. Okay, so so I've done some literature here. Okay, you can read it. The fourth chart I have drawn is of room type versus price graph. Okay, so as we can see that entire home apartment is having the highest price, and followed by the private room, and the third one is the shared room. So shared room has the lowest price, average price. Okay, the fifth chart is of number of reviews versus room type. So which room is more popular in the Airbnb dataset? So private rooms are very popular. A lot of reviews are there of private rooms. Second is entire home apartment, and lastly shared room. Okay, so shared room no one wants to talk about. We can clearly see. The sixth graph I've plotted is the availability versus price. Okay, so as we can see that no prior correlation between these two variables were uh, able to get. Okay, but we can visualize one thing is that Manhattan has the highest number of availability. Okay, the next graph I've plotted is number of reviews versus price. So in this graph also we cannot see much correlation between these two variables. But yes, entire room apartment has the largest number of reviews. Our next graph is of top 10 hosts charging the highest price. So these are the list of the top 10 hosts that are charging the highest price. Jelena, Rain, Catherine, all these guys, they are charging the highest price of the room. So why I've plotted this graph is basically to understand that why these people are charging so much. So what all special amenities or features they are offering? Either they are offering complimentary food and beverages, or they are offering free parking and all. Okay, so we need to check what all things extra they are offering, and accordingly we can make our business decisions. The second, the followed by graph is of busiest host. Okay, so the hosts that are most popular, the most busiest host in the data set. Okay, so Dona, JJ, Maya, all these hosts the high are having the highest number of popularity. Okay, so we need to just either call them or we can have a virtual discussion with them, that why are they so much popular, what all different initiatives they have taken, uh, so that their business is growing so fast. Okay, and similarly we can help other our channel partners who are lagging behind, we can help them to grow. Our next graph was of distribution of minimum nights by room type. So entire home apartment, you can see that highest number of nights are there. Uh, Similarly, average price versus the neighborhood. So Manhattan has the highest price, followed by Brooklyn, and the last are the Queens and Bronx. So as we can see that Manhattan has the, I suppose maybe there may be a reason that Manhattan has the highest real estate prices. So this is maybe a reason why the Manhattan price is uh, seen at a higher end. Our next graph is of neighborhood versus number of reviews. So Brooklyn and Manhattan are having the largest number of reviews. So this is only the single graph that is having the highest correlation. So reviews per month versus number of reviews. As you can see, positive correlation is there between these two variables. So these two variables are directly proportional to each other. Similarly, neighborhood groups versus availability. So Staten Island and Bronx are having the highest number of availability, 365. Okay. Top three popular neighborhoods are Silver Lakes, okay, and Richmond Town, are the top three popular ones. Top 10 neighborhoods with highest price. So these are the top 10 neighborhoods having the highest price. So we can similarly we can ask these, do a research why they are charging so much. Okay, whether maybe due to the high real estate prices over there, this may be a reason. Top three neighborhoods with median minimum nights. So Bay Train, Staten Island has the highest number of minimum nights. Okay, so maybe it's a tourist place. People love to go there and they for vacation and all. Okay, so these are the top five costliest list properties. Okay, so maybe they are on business area or posh area. So maybe this may be reason that their price is at a higher end, or maybe that they are very much luxurious or suite type apartments. So maybe this may be also a reason why they are charging so much. Now we are going towards the multivariate analysis. So I have drawn a correlation graph heat map. So basically we can the heat map is the red one showing the highest correlation, and it goes down down down, and blue one having the no correlation. So we can see number of reviews and reviews per month is having only the correlation, and rest we can see no other correlations are there. Similarly, pair plot I have also plotted as I have already told. So only one correlation I have seen, review per month and number of reviews. So that we can see, and the other are of no use. Okay. So this marks the end of the exploratory data analysis. So conclusions that I've drawn from the above analysis that I will be sharing it with you, that is proper pricing tool. Firstly, to address proper price outliers by implementing dynamic price tools to help host set competitive rate and maximize return. Okay. Then second is the guest engagement. As we can see that very less number of people are engaging in review section. So what we can do is that we can offer some discount as at from time to time. so that people remain engaging and they do the review properly. Okay. Thirdly is neighborhood focus. So there are some neighborhoods that are having high demand. Suppose, for example, Manhattan and Brooklyn, and at the same time there are some low engaging neighborhood also. So okay, so, for example, Staten Island and Bronx. Okay, so we need to cater the high demanding area as well as try to boost the low demanding areas also. Okay. Then state erosion. So we should promote some, give some extra coupons or discounts so that the uh, people they extend their stays. Okay. Room type differentiation. So we have to tailor the strength of entire home apartment. As you can see that it is the highest popularity it is gaining. So we can tailor its strength, and as well as at the same time we should also focus on the shared room. We can um, we can mark it as a affordable means. Okay, so we can market accordingly. Okay. Then successful housing, as I already said, we should ask their successful host like Donna and all to share their success stories. Okay, so that we can uh, we can get a clear picture, and accordingly we can help those channel partners that are lagging behind. So now I'm coming towards this price prediction model. So first of all, let me say one thing is that challenges. So the major challenge was that no correlation was found between the variables. Uh, no much correlation was found. So it becomes difficult in order to prepare a model for that reason. Okay, so now what I've done is that since less number of correlation was there, so I've taken some categorical variables also into consideration for preparation of ML model. So what I've done is that neighborhood group and room type I've converted into numerical values. Brooklyn 1, Manhattan 1, Brooklyn 0, Manhattan 1, like this. And then what I've done, I've taken four features, okay, for preparing the ML model: neighborhood group, room time, price, and availability. Okay, so among this four group, neighborhood group, room type, and availability 365 will be my independent variable, that is my X, and price will be my dependent variable, that is my. So SNS. So now I've plotted a heat map. Okay, as you can see that no correlation is there. Then what I've done is that, so in order to handle the outliers, I've used quantile methods. So my outliers have been removed. Then I've done a log transformation of y. Okay. Now I've imputed a simple imputer and no, sorry. Now I've done trend test suite, and I've splitted the entire dataset into training and test. 20% I've taken the test dataset and 80% I've taken the train dataset. Okay, so now I have built the model. Okay, so now I'll be filling the model, making the models. Okay, so first I have done with linear regression. So as you can see, linear regression is giving not that much accuracy. Okay, so the second model I've used XGBoost. So XGBoost, let me give a small introduction about it. So basically, XGBoost is based on the gradient boosting framework, which is an ensembled technique. It basically what it does is it builds new trees that correct the error of previous trees. Okay, so I've done some. This I've taken some hyperparameters of. Okay, so grid search CV I've used. So in order to do the hyperparameter tuning, and accordingly, the machine has used the best parameters, and it has computed the calculations. So I have drawn these um, uh, means square error and all parameters accordingly. And the last, I've used artificial neural network. So since it was a regression problem, so I used sequential regression. So first, as you can see, the first layer is the input layer with 64 neurons, and then I used three hidden layers of 32 neurons. Okay, and the last layer is linear activation I've used for the last layer. Okay, and I've trained this model for 100 epochs. Okay, and I've got a pretty good accuracy. So I've drawn the conclusion that XGBoost is the best performing model with the lowest mean square error and root mean square error, followed by ANN. Okay, and the last least performing was the linear regression. Okay, so this was all about my project. Thank you so much for listening.